In this project, we explore and complete two types of movie recommendation systems, including item-based filtering and content-based filtering. So let me introduce item-based filtering first. The idea of this method is it recommends items similar to the user's previous favorite items to them. Different from content-based algorithm, the item CF does not use the attributes of items themselves to calculate the similarity. It mainly calculates the similarity by analyzing the user's behavior records related to items. For example, the algorithm regards item A and B as similar if most users who like item A also like item B. The concrete methodology is, first, calculate the similarity between items, build up similarity matrix. Second, calculate users' interest score in new items using similarity matrix. And finally, select the top K items with the highest score for recommendation. So let me look at the first step, calculate the similarity between items. The formula we use is like this. The denominator is the number of users who like item mu, and the numerator is the number of users who like both item mu and item new. But there exists a problem that if the item mu is quite popular, which means the n mu is very large, and it will result in the similarity very close to 1. It will recommend hot items all the time, which is not good. So we can improve this formula by penalizing the weight of item n mu in case it is too large. We can do some further improvement by penalizing the active users. The reason is that if there is such a user, he is a movie critic and he has seen a lot of movies, which results in a lot of similarities between two movies, thus interferes with the measurement of similarity between movies. So we simply multiply each numerator by this value to do some improvement. And the second step is calculate user interest in new items. Suppose we find K similar items and recommend N items to users. User mu's interest in item J is calculated by the following formula. The WJI is the similarity of item J and item I, and the R mu I is the user mu's interest in item I. So look at this picture. For each user, these are the movies he has rated before, and we search out the movie similar to the movies he has watched, and we calculate the user's interest level of these new movies. And finally, we sorted these new movies and select the top K movies for recommendation.
So this part is the implementation details of the item-based filtering. This program is based on the item filtering algorithm. The specific core idea of the algorithm has been elaborated in the previous section. Basically, it is to find the most K-similar movies according to the select user's previous watching history, and then recommend 10 movies to him. Before the program begins, we did some data pre-processing so as to get a better performance about the model. Specifically, we filter out the movies whose scoring number by people is less than 10 and recognize them invalid movies, and also we filter out the users whose numbers of scored movies is less than 50 and recognize them as invalid users. Therefore, after pre-processing the data, this program firstly defines a class named class item base CF in order to achieve some functions in this class. Secondly, we define the first function who initializes 7 parameters such as the train set, the most similar movies, and so on. Furthermore, the function getDataSets is used to get the dataset from the CSV file. The parameter pivot is a proportion to get the training dataset and test dataset. Next, the function loadFile is to decode the data whose form is binary. And following is the calculate movie similarity function, which is to calculate the similarity between movies. We use 3 for loops to calculate the numbers of movies each movie has been rated, and then we count the co-rated users between items. What's going on? We use the cosine method to calculate the similarity matrix. You know, this is very important since we need to use the similarity matrix to recommend movies to selected users. And then in the recommend function, we need the recommend function to find the top K similar movies and recommend N movies for the targeted user. If the user has already seen it, it's not recommended. And last is the evaluate function. We use 3 indexes to evaluate our model: precision, recall, and coverage. And next part is our experiments. This program uses the movie lens dataset provided by group lens. We want to review the impact of K value on algorithm performance. The value range of K is 5 to 320. And under each value of K, the data is divided and evaluated 5 times. And the average value of the 5 times is finally returned as a result. So this is our experiment results. You can see the K40 gets the highest precision. And this is our diagram of the 3 indexes. We can notice that as the K value increases, the more similar users are considered, and the greater is the coverage of the types of items involved. But then the coverage will decrease because if the K value exceeds a certain size, there are enough users considered, and the predicted items are getting closer and closer to the fair rate of the mainstream public and tend to be popular items, so the coverage rate will decrease. And then the precision. When the K value is 40, the precision gets the highest. With the K still increasing, the precision begins to decrease. So we finally decide to set the K in 40. The last is recall. As the value of k increases, the number of similar users it considers increases, and the preferences of users can be more and more discovered. The recall rises first, and then tends to be stable and remains unchanged. Recall is not very sensitive to changes in the k value. As long as the k value reaches a certain threshold, it will have little impact. This is our model efficiencies and improvements. This model usually needs approximately 1 minute to execute because it needs to calculate the movie similarity matrix. So basically, we can still improve the execution time. And the dataset is a rating dataset, and users can rate movies on 5 different levels from 1 to 5. This paper focused on the top-end recommendation problem in the implicit feedback dataset. So the scoring records in the dataset are ignored. And this is our conclusions.
However, there are still some shortcomings about item CF. The first is we calculate the similarity through the interaction record between users and items. So it can't effectively introduce the content or attributes of item itself, which results in the omission of valid information. So maybe content-based algorithm can solve this problem. And the second is in our experiment, the similarity between movies is calculated by the number of people who have rated the movie and does not reflect the value of the rating. So it recommends movies those users might want to watch rather than giving a high rating. So as an improvement, we can use cosine similarity as an alternative, which considers different movies as vectors and a user's rating as elements in the vector, thus takes rating into account. Compare with cosine similarity, Pearson correlation coefficient can be better. So that is all about item CF.
The next part is a content-based movie recommendation, which captures similarity based on the movies and implements user interaction on the front-end page. There are two main methodologies in the system. TF-IDF is a common algorithm of text feature extraction. The value of a word can be calculated by multiplying term frequency and inverse document frequency. Another methodology we use is logistic regression, which is used for classification. The function seems like a normal regression model, but on the left side is a logic transformation. It's applied on the odds and the probability of success divided by the probability of failure. And for binary classification, the critical value is 0.5. And next, as for the implementation, the whole structure of our content-based system is displayed above, and we shall elaborate details in the flowchart. Firstly, construct movie dataset. We crawl movie list from Wikipedia and crawl movie genre from the MovieDB website, and then we process data into the main dataset. And next, we conduct recommendation by text feature extraction and calculate the similarity based on the movie's information.
In order to give more information to users, we also conduct a sentiment analysis on movie comments and show whether it is a good or bad comment to users. It is divided into 3 steps. First, we prepare our data. We download the stop words in NLTK package and our training data from Kaggle. Then we use this data to train our TD-IDF vectorizer and use the function pickle.dump to store it into a file for later usage. After that, we split our data into train set and test set. We fit 7 classification models on train set and test them on the test set. Then we use accuracy, recall, precision, and AUC as our criteria to compare them and store the best one, which is the logistic regression model, to a file. In the main function, we get our already trained vectorizer and model from files and grab the movie comments on the website. We analyze the comment data with our models and show whether it is a good or not comment to the users.
To realize complete visualization, we are going to use Flask. There are 3 paths here, including Python file, HTML file, JavaScript, and CSS file. Connecting the 4 kinds of files realize the visualization of recommendation system. For the Python part, it creates an instance of Flask, also known as app. By app.root, we can define the content of each page in our website will be on display. In details, we define home function in the home page, also known as search page. Besides, recommend function in recommend page is going to deal with information showing on the website. By AJAX request and the beautiful soup function, we can acquire the basic information and reviews about the movie input. Also, by calling the RCMD function, we can get what will be shown on recommendation part. Finally, we can construct and render our website in HTML files and connect these 2 files by render template function. As to the HTML file, we get 2 files for homepage and the recommend page correspondingly. The 2 file styles are the same. Both use Google Fonts, Font Awesome, and Bootstrap 2-side fonts, and something about that. Also, we use that a hyperlink, which can jump to our GitHub, and the later claim is placed in the lower right corner of the page. More specifically, when it comes to the homepage, we borrow autocomplete function from JS Deliver, a free and open source, which make the search bar complete. For the recommend page, we place information about the searched movie on the top, and then the detailed information of the actors and the actresses follows, which is hidden by the cast of the person and can be shown by clicking the picture. Then we show users the reviews and if reviews are positive or negative. At the bottom of the page are the recommended movies. One thing to mention is that the information displaying in the recommend page is realized by the JavaScript file. In fact, we set the API of TMDB, and then we can acquire the movie data by AJAX request from the movie database.
Then comes the experiment part. For web crawler part, we first gather the two columns, title and cast anchor, into a data frame. Then recall the functions to get runner and process the information of the latest 3 years into the main file. And for the sentiment analysis part, we get our training dataset from Kaggle. There are 2 columns and 25,000 rows in total. The review will be 1 if it is a good comment and 0 if it is not. Then we split our data into train set and test set, and fit 7 classified models on the train set respectively. We compare the models on their behaviors on 4 criteria based on the test set. From the table above, it is obvious that logistic regression model gets the highest score in all aspects. We train our vectorizer on the training dataset and store it into the file. And then we also store the already trained logistic regression model into a file.
The homepage with autocomplete as shown above, we can see there is a little icon in the upper right corner of the page. It's a button to jump to our GitHub, actually, and the little claim saying made by cool guys in the lower right corner of the page. When it comes to the recommend page, we can have access to the basic information of the movie, and we can know more about the actors and actresses by clicking the cast. The review part lists some reviews and whether it's positive or not with an emoji. Finally, we recommend some movies for users with posters to the movies. If users are interested in some movies, just click it and then the website will show the page for it. For our content-based recommendation system, it's equipped with a website which can be accessed via localhost. For the front end, we find ways to render our pages and make it more pretty and well-structured. For the back end, many methods have been tested to see if they work well on our project and match our goal. Even though our recommendation system is complete and content-rich relatively, we still have something to do to optimize our system. First, some deep learning algorithms can be included. But for computing resource considerations, we didn't choose those algorithms to make sure our website works smoothly enough. Besides, our movie database is limited because of limited resource. Our computer cannot support the database including all the movies. In this project, the 2 recommendation systems implement recommendation from the perspective of users and movies, respectively. Thanks for listening.